noise. So I worked out what was wrong yesterday on Monday when things were trying to collide and they weren't colliding with one another. If we look back at where are we? Unity. Give me Unity, or give me no, not Unity. Unity is there. Why is Unity not appearing on my screen? Because it's just got lost. File, open project. If we look back at the asteroids project, somewhere, not there. Where is the Unity window? Yes, there we go. Where are we putting it? Okay, give me a tiny little window. Let's make that a bit bigger. So if we look at asteroid on the sphere collider, so it's a bit dark. Let me zoom in. On the collider, there's this is trigger field, which so it's a checkbox. It's either true or false. The problem was that we hadn't turned that on. So if we turn that on, it should work the way it was before. So if we went back to our scene, oops, open our scene, and we were using. So we were using let's go back to that prefab. So now if we do this, our asteroids, we should be able to, yeah, so now if we collide with asteroids, they disappear. So that's what we were expecting. So, but if we turn that is trigger off, then that behavior doesn't happen. As I can show you, if we turn that off, then now if I run into things, they don't disappear. All right, so you need to have if you want things to cause trigger events, you need to have need to make sure that the collider has the is trigger field turned on. I had forgotten that I'd done that, and I didn't write it in the notes. So I've put it in the notes in the slides from yesterday, or from Monday, and there's a new copy up on the web page which has that slide in there, just to make sure you know about that. But what I'm going to do today is I figured I'd been spending a lot of time. Let's go back to the beginning. Plowing full speed ahead, and I really got a long way further through the syllabus already than I was expecting to. So rather than hit you with more material right now, we're going to spend today's lecture and possibly the next one as well doing another worked example from scratch. Just to show you how the ideas that we've already covered will apply to a different example other than asteroids, because you want to program other things than asteroids. And so picking again on the arcade games from my youth, I've decided to implement Breakout, because it's a simple game. For those of you who aren't familiar with Breakout, you don't know what you're missing. You should go out there and play it. Again, it's another old Atari 2600 game. Very simple. So I've written a storyboard for it. Very simply, you controlled the paddle at the bottom of the screen. You could move left and right. There was a ball which would bounce off your paddle and off the walls, and then there were a bunch of bricks up here, and when you hit a brick, it disappeared, and your objective was to get rid of all of the bricks. So my storyboard shows the pieces and then all the important interactions. So when the user presses right, initially the paddle and the ball are connected together, so they'll move together. And again, if you move left, they'll move left. But when you press space, the ball is released and it starts moving on its own accord. The ball moves diagonally, and when it hits the wall, it changes its left-right motion. When it hits a brick, it'll change its up-down motion, and it'll start moving downwards. Actually, it's a little bit more complicated than that, because later on we're going to be hitting bricks from other sides. So I've done a couple of slides to show in my storyboard to show exactly how brick collisions would work. If we're hitting the top or the bottom, then we're changing the up and down behaviour of the ball. So if we hit it on the bottom going up, we'll then go down. If we hit it on the top going down, we'll then go up. If we hit it on the sides, it doesn't change the up-down behaviour, but it changes left and right. So again, this doesn't change the left and right. So if we're going that way, it'll bounce either, it'll continue going left or right. It'll just change up and down. This one changes left and right, but doesn't change up and down. And finally, there's a corner case where if we actually hit the brick on the corner, we want to change both left and right and up and down. And so the four corners will head off in different directions. So to summarise, that's kind of the changes that we're going to make, depending on where we hit it. And we can sort of divide the world up into these 8 quadrants. If the ball is in this quadrant when it hits the brick, then it'll bounce off that way. If it's in this quadrant, it'll bounce that way, and so forth. Well, they can't be quadrants if there are 8 of them. You could have 4 quadrants. What do you call it, an octant? Anyway, that really doesn't matter. So the nice thing about this is that we realise it basically means rather than having 8 different cases, we can really treat it as 2 separate issues, whether we are above or below the brick and whether we're left or the right of the brick. When we're below the brick, if we hit the brick from below, we'll always change the up-down. If we hit the brick from above, we'll always change the up-down as well. But if we hit the brick from in between, then we won't change that. So we can just think about up-down in terms of 3 cases. If we're below the brick, we start going down. If we're above the brick, we start going up. And if we're in between, then we don't have to change the up-down direction. Similarly, we can just treat the left-right as 3 cases. If we're here, here, or here. And so we don't need to worry about, so rather than having all of those 8 cases individually, we can just think separately about this, and combining those means that when we're in this corner, it'll both change this one and it'll change this one, which gets us what we want. So working this out in the storyboard is helpful before we start programming, because if we just launched into writing this code, we could have written a whole mess of code before we realised that it was actually quite a lot simpler process than we would have thought. So it's nice to work this out in a diagram first. When we hit a brick, also the brick is removed. So the ball bounces off, but the brick disappears. And the ball and paddle are moving independently now, so it's worth putting in a slide to indicate that. The ball will also change direction when it hits the paddle, and in fact, because the paddle is also a cube or a rectangle, we can use the same rules for colliding with the paddle as we can use with bricks. So if we hit the corner of the paddle, we can bounce off diagonally, but if we hit the top, we can bounce off. We can just change direction. If we hit the sides, then we're going to go the wrong way. And, you know, that sucks, but yeah, whatever. If we've got rid of a whole bunch of bricks, we hadn't already talked about the top wall, but obviously the top wall also changes up and down. And interestingly enough, again, we can treat the 3 walls in the same rules as the bricks. So we really don't have to treat them separately. We can just say, this is a very large brick, which if we hit it from this side, we'll do that. Now the fact is we'll only ever hit it from this side, but that doesn't really matter. The code doesn't need to know that they're any different. So this is nice, again, that it saves us having lots of separate cases in our code, because we can really treat the paddle, the bricks and the walls all as the same kind of object. Now there'll need to be some differences, of course, but because they don't all behave exactly the same way. But in terms of collisions, we can treat them the same. And also, if the ball misses the paddle and goes off the screen, then we're going to call that a game over. And that's the game that we're going to make. Right? So now I'm going to launch into actually doing that. Let's leave that one there. Oh, okay, let's come down to here. So I created a project, created a breakout project. I'm going to sit down for this. I don't want to save that. I didn't bother including any of the standard assets because they're not really useful for what we want to do. So we have an empty project with nothing in it. Standard assets just waste space because we'd have to make a big copy of them also. So what we're going to do is start with, where's our cameras there? Okay, our camera's pointing in the Z direction, which is what we want. So we can start by putting some bricks in the world. We'll do everything, actually the first thing we'll do is we'll come to the camera and we'll give it change the skybox to be a colour that, there we go, a white colour. So the screen will be white, that looks good. And we'll add a light because it's important that we, wait a second, I'll just turn that off. Don't quit. And we'll add a light because we're going to need a light when we get there. So we'll create a directional light and we'll attach the light to the camera. Whoops. And we'll set the light's position to be 0, 0, 0, so it's exactly the same spot as the camera. So the light and the camera are in the same place. There's nothing really to see there yet, but there we have it. Okay, so the first thing we're going to add, we're going to just make the objects that we're going to need. So this is easy. They're going to be, we'll create the ball first. So the ball will be a sphere. We'll put it initially in the middle of the screen, and we'll need to give it, so it automatically gives us a sphere. When we create a sphere, it automatically gives us a sphere collider attached to it. We're going to want that to be a trigger, so let's put that as a trigger now so that we won't forget about it later. Right, so, and we've got to make that look, so at the moment that looks like a white ball on a white screen, which isn't very nice. So we'll give it some colour. We'll come down the project and create a material. And we'll pick a colour. Any choices? Colour for ball? Preferences? No? Okay, it's going to be green. Okay, so this is the, we'll give that a name. It's ball colour. Ball. I'll just call it ball. And we'll actually give this the same name, we'll call that the ball, and we will attach that to there. Right. Now if we look, there we go, we have a nice bright green ball. Now let's create a paddle. Game, create other cube. Let's call that paddle. And let's stick that at 0, 0, 0. Let's move it down a little bit, but let's face it that way, whoops, not that way, that way. Zoom in a bit on our scene. Okay, so we want to move that cube down there. Let's have a look, is that about where we want it? Okay, let's move it up a bit. It's an ugly looking thing. Let's give it some, let's give it also a material, so we can call this the paddle material. And we'll make the paddle, I don't know, pick a colour, something around there, brownish kind of colour, just because I feel like it. And we'll stick that on the paddle. So then the paddle is brown. Ah, there we go. Okay, that looks much better. Now that's not a good shape for it, so let's actually stretch that. We want to stretch it in about that. That look about the right size. I think we might make it a little bit shorter as well. Maybe a bit higher than that. Whoops, 7. That kind of looks nice. Okay, so there's our paddle. Now initially we can put these into an initial arrangement. So we might put the ball down there into the middle of the paddle. There we go. So how does that look? Okay. And what we can do actually, no, I'll leave that for a moment. Okay, so the other thing here is you can see Let's actually maximize that. This is giving us a 3D view. So the ball and the paddle are kind of view. We're looking down on them slightly because the camera is actually above them. Let's make that a bigger screen. 5:4. There we go. That's nicer. So one of the tricks that we can do is go back. Is we can, if we want to do so a normal camera. If we look at the camera in the scene, so if we look at it from above, a normal camera has some level of perspective, right? So it comes out. You can't see that. But the camera's there, it comes out in a triangle. What it can see comes out in a triangle like that. And so it gives you a perspective view, like as if it was from a real camera. What we can do, though, is if we want to have more of a flat top-down view on our game than a perspective view, we can change the camera by selecting orthographic here. There's an option over here in the camera to turn it on to be orthographic. An orthographic camera has no sense of perspective. Everything, no matter how far away it is. So a perspective camera, things that are further away are smaller. An orthographic camera, everything is the same size, no matter how far in the distance it is. This eliminates the sense of perspective. So if we go back to the game, well, okay, so there's a problem here. There's a tiny, tiny little paddle there in the middle of the screen, and that's because the orthographic size, an orthographic camera has completely different parameters, so we've got to fiddle with the orthographic size. If we make it about 5, that looks about right. So you see now that there's no perspective on here anymore. We can't see the top of the brick because we're just looking straight at it, and the ball is now coloured sort of more normal, more flat rather than a top-down view. So that's probably more appropriate for a game like this. Now if we have, in fact we might make the ball a little bit smaller because I think it looks a bit big. 0.5, 0.5, 0.5. That's a bit too small. 7, 0.7, 0.7. That looks good. Okay, and we'll move it down a bit. So we zoom in on our scene, not from the top, from that side. Okay, so there we go. Nice starting position. Let's make some walls. Whoops, keep doing that. Game object, cube. Okay, so this is, let's call this the top wall, and we'll make it, so we'll move it up to the top of the screen. We can't see it at the moment, so let's put it back in the middle of the screen, 0, 0. Oh, we can't see it because it's the wrong colour, because there's no shading anymore. Or let's give it a different colour. We'll make our walls, I don't know, blue. There we go, that's a nice enough colour blue. And we'll add the wall material and we'll stick that on our top wall. Okay, now can we see it in our game? There it is, okay. So now let's stretch, let's move that up a bit first of all. So it's at the top of the screen. Can move it up a bit further. That's good. And let's stretch it so that we want to stretch it in the X direction. So let's make it like 10 times. Needs to be bigger than that. Make it 15 times. There we go. And that'll do as the wall at the top of our screen. In fact, we might move it up a little bit more. Cool. Now I'll just make 2 copies of that rather than create new ones, and I'll call them left wall and right wall. And what we'll do is we'll rotate those so that the left wall is rotated. Now we're rotating around. The Z-axis is the one sticking out of the screen. That's one we want to rotate around. So we rotate 90 degrees around Z in order to get that. And we'll put that, so that's currently in the middle of the screen. We'll move that down and off to the right, to about there. Oops, too far. To about there. There we go. A little bit more that way. Right. And we can create another one. Where's the other one gone? The right wall, we'll rotate it as well. And we'll stick it on the other side of the screen. So in fact, what we can do is take the coordinate of this one, that one, and stick it into here. And then we'll negate it because we know it's on the other side of the screen. There we go. Ha. And we can take the y coordinate here and stick it into here. There we go. So now they're in the same positions on either side of the screen. Hey, and so we have it. Not quite sure why those corners are different colour, but anyway, we have walls around our screen, which is good. What we might actually do, just for neatness sake, rather than any functionality, we might group those walls together. So if we create an empty joint in our hierarchy, we can add the left wall, the right wall, and the top wall all to the walls joint, and then we can then it just groups them together nicely so that we can see all our walls as part of our walls in the hierarchy, rather than having them all out in the top level of the hierarchy. Okay, so that's all the easy static hardware done. Now the other thing we need to do is create a brick, or create a bunch of bricks. So let's create a new cube. Let's call it a brick. Let's stick it in the middle of the screen so we can see it. Okay, let's give it some colour. Create a new material. We'll make our bricks pink, just because we can. There we go. Now where is it gone? Oh, okay. We haven't put the material on the thing. Brick. And we'll take the brick here and we'll stick the material on it, and there it is. It's a nice pink brick. And while we're at it, because we've got so many materials, again, to make things a little bit neater, we'll create a folder here and we'll call it materials. And we'll put all our materials in there so that we don't have everything lying around in the same directory. That makes life a bit easier. Our brick is a bit of an odd shape. We'll want to make it, say, about 0.8 by about 0.4. That's a bit too small, 0.5. That kind of looks about the size that I want. Actually, I might have 1. Yeah, 0.6. That looks a good size. Okay, so that's my brick. Now what I could do, if I wanted to, was create, duplicate this brick in an endless number of times and arrange them there. Because all our bricks are going to be the same, first of all, we probably want to make a prefab of that brick, rather than, so that we can put scripts on the prefab which will apply to all the bricks rather than apply to just one brick. So let's create a prefab first, rather than hand create an enormous number of bricks. So that's the brick prefab. We'll drag the brick onto there, and now we can delete our original brick and we have our brick prefab, and we can drop as many brick prefabs into the world as we want. I'm assuming that will work. Yeah, we can drop. Okay, so we can create bricks like that. Now if we wanted to, I could lay out by hand as many bricks into the pattern that I wanted to. So I could make, if we go back to Keynote, wherever it was, I could, not there, thank you, grab that. Why is that not working? Grab that and go up there, thank you. So, but, we want to have a lot of, there are 4 times, there's probably 40 or so bricks there. I don't want to have to create 40 separate bricks by hand and lay them out. So what I'm going to do, instead of putting the bricks in there by hand, I'm going to actually write some code to create the bricks. So let's do that first. What we'll do is I'll create an empty object here, which will be the container, the joint container for all the bricks. So that's our bricks. A bricks object, I'll stick that in the middle of the screen somewhere. In fact, I'll stick that at 0, 0, 0. There we go. And now I'll add a script here which creates a bunch of bricks. So create, I'll call it create bricks. Okay, so what we don't need is an update function on there, but what we do need is a start function. So function start, empty parentheses, that's going to be our function, and we're going to create bricks in a rectangle. Okay. Now what we're going to need to know is what the prefab is. So we're going to say brick prefab, and that's going to be a game object, and that's going to be the thing that we're going to make our bricks out of. Now, because we want this script to be reasonably flexible, we'll actually say put in variables for parameters of how many layers. That'll be an integer, and we'll say initially, let's say 5, and we'll say also how many bricks per layer, and we'll say that's also an integer, and let's say that's 10. Let's see how that looks. Okay. So what we'll do in order to create these, this is going to be doing. So we're going to be doing the same operation over and over again. And if we have 5 layers and 10 bricks per layer, we're going to do the operation 50 times, right? So when we're doing something a known number of times, what this calls for is a for loop. Now, rather than have one for loop that does it 50 times, we can actually have 2 for loops, one inside the other, which the outer for loop creates each layer, and the inner for loop creates each brick. So what we'll say is for, I thought I had a comment in there. There we go. Good. Okay. For var layer equals 0, layer is less than layers. Actually, let's call that, I hate calling that. Whenever it's a number, I usually label it n and then the thing. It's just a naming scheme that I use in order to make it clear that that's a number of layers. So, I mean, that's totally up to me. That's like your choice for readability, but it works for me. Layer plus plus. So this outer loop is going to create each layer from numbering them from 0 up to the number of layers minus 1. So there's going to be, so if n layers is 5, this loop's going to run 5 times, creating 5 layers. Now, we can do it another for loop in here. For, let's call it b equals 0. B is less than bricks per layer. B plus plus, and this will create each brick. So now what will happen is that the outer layer will run, the outer for loop will run once, it'll run around here 10 times, creating all 10 bricks in that layer, and then when it's finished, it'll drop out of there and come back to the top here and do the next layer, which will go around here another 10 times, and then come back to the top and it'll do the outer loop will happen 5 times, but each time it does the outer loop, it'll run the inner loop 10 times. So in total, we'll create 50 bricks. And this kind of nesting is pretty common in programming. Often, especially when you have a two-dimensional array of things, like we have this rectangle of bricks, it's quite common to have 2 nested loops like this, the outer one doing layer by layer by layer, and the inner one doing all the things within the layer. If you're going into 3 dimensions, we could make a 3-dimensional array of bricks by having, you know, each layer, then each row within the layer, then each brick within each row, if we wanted to go in 3 dimensions. But we won't do that. We'll just do a 2D game. Okay. So we need to create a brick. So every time we do this, we instantiate, if I can spell it, our brick prefab. And what we're going to do is set the, we want all the bricks to live within the, in our hierarchy, we want all the bricks to sit within this bricks object. So we can, so what we'll do is we'll set the parent, for every brick we create, its transform has a parent, which is the object that it is within, it's the object that it's under in the hierarchy. So in this case, because this script is going to go on the bricks object, we can say that the parent of each brick is this transform that we're currently working on, which is the bricks object. So all our bricks will be created within there. Now if we ran that, at the moment, let's stick that on our bricks object and run that. And we've got an error because I didn't instantiate the, I didn't set the brick prefab. Let's do that, brick prefab. Right, now there's only, it looks like there's only one brick there, but there's actually, if we come down to our, it's really hard to see on this light. I might close those blinds a little bit. Oops, wrong way. Oh, that's slightly better. Just need better intensity over projectors. So if you look in the hierarchy anyway, under the bricks object that we created in there, whoops, there's a whole bunch of, well, there's 50 clones of the brick prefab sitting in there. Hopefully you'll be able to see that better if you look at the video. But that's all right, but our bricks are still all sitting in the middle of the screen, which is not where we want them. So we should make some code to actually arrange them where we want. So the easiest way to do this is, well, so what we're going to need to do is to know how far apart our bricks are going to be separated. So we could say we need two more variables, which is say, we'll call them delta height, which will be a float, and delta width, which is also a float, and we'll call that both 1 for starters. So delta height is how far each brick is from the brick above it, and delta width is how far it is from the one to its left or right. So now we can say transform. The easiest way to do this is actually just to say, how do we do this? So now we have to work out what position our bricks are going to go into. I'm going to actually work this on the board if I can find a piece of chalk. Okay, so we have to do a little bit of math. Is there any chalk? There's blue chalk, but that looks totally unreadable. No. Okay. I'm not going to trust it to blue chalk then, that's silly. Let's look at our diagram. Let's not look at my Facebook account. So let's assume that the bricks object itself, so the parent object is, we're going to put it right here in the middle of the thing. So then for each layer, so if there are layers less than, actually no, if we put it there, okay. So we're creating a brick initially there. For each layer that it's in, we move it either up or down. Moving either up or down is annoying. Let's start off with creating let's put the center there. We'll put the center there when we get to it. All right. So then the brick 0. If we number our bricks from 0, our layers from 0, 1, 2, 3, and our bricks from 0, 1, 2 to 10, then this is brick 0, 0. So brick 0, 0 is at the point. Brick 0, 1 is moved right by one width unit. Brick 0, 2 is moved right by 2 brick units. Brick 0, 3 is moved right by 3. And then also brick 1, 0 is moved down by 1 height unit, brick 1, and so forth. Okay, so we can do this really easily. Rather than try to calculate the x and y, all we'll do is say, tell the brick to move. So we'll say brick.transform.translate, and we want to move right. So we'll say vector3.right. And the distance we want to move right is delta width. But we want to move delta width multiplied by the brick number. So the brick 0 doesn't move at all, brick 1 moves 1 delta width, brick 2 moves 2 delta widths, and so forth. And so that will make our bricks spread out horizontally. Now we'll do the same thing in order to make them, we'll make them move down. Oh, there isn't a down. Okay, so we'll say up, negative up, and we'll make them move down by the height multiplied by the layer. Right? So bricks in layer 0, and now you get the kind of idea why computer scientists count from 0, because it's convenient here to number these things from 0, because the 0 brick, which is, so if this is brick 0, it moves by amount 0, and rather than if we numbered this as brick 1, then the equation here would be slightly more complicated. So it's just easier in general to number things from 0. Most of the time, numbering things from 0 will be natural, which is one of those things. Right. So now if we run that, okay. So there are our bricks. Now I said that we've started them because they're all children of the bricks object. They're all located relative to that bricks object. So if we go in the scene and we grab that bricks object, we can drag all of our bricks in one go, and we can put them kind of where we want them. Now that's not going to, so that's about right. Now unfortunately it's not going to save that value. We've actually put them a little bit too close together, but okay. So we'll move this just to there. Well, remember this value is negative 4.6, negative 4.5. Now unfortunately it's not going to remember that value, so let's move that to negative 4.6. What was that? 4.5. Let's try running that again. Oh, and why has it gone back to there? Huh? What? I don't understand. Let me check on that. What the? Oh, I know what's happening. That's because. Okay, so what we need to do is let's actually set the initial transform. So brick dot transform dot position equals vector 3.0, because it's not creating it at the 0 position. So there we go. So that should still not do what we want, because argument out of range exception. Okay, where's that? Hello? Where is that happening? I don't know. Start index. What the? Okay, that doesn't seem to have anything to do with me. Okay, so why are our bricks not being created at the right position? They should be created at, have I saved that? Yes. Our bricks object is up there. I'm confused. The bricks are all being created at, why is that happening? Okay, let's go here, see something. Bricks, brick. That's curious. For some reason or other that brick has been. Okay, let's do this instead. Transform dot position. I wouldn't have expected that to. Oh, I know what that is. Oh no, I don't. Let's have a look at something. Help. Scripting manual. Transform. Position. Right, okay. What I wanted was, okay, so I was setting position, but position is the position in world space, what I wanted to set was local position, which is the position in the parent space. Go away. So what I'm going to do, so that is that's not the best way of doing what I just did. What I could do is say local position equals vector 3.0. 0. Okay, so relative to its parent, it's at 0, 0, 0. What I was doing before was setting it to 0, 0, 0 in the world rather than 0, 0, 0 relative to its parent. So that now should presumably do what we want. Yes, all right. Okay, those bricks are too close together, so I'm going to adjust that value on our bricks. I'm going to make them a little bit further apart. So make that 1.2. Okay, now they're right far apart, but there are too many of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're going to just say 9. Or we could make the brick smaller, but that sort of, we'll just say 9 bricks per layer. And I'm going to move that whole thing slightly to the left. And that looks good. We're going to actually make them a little bit, delta height a little bit smaller, 0.8. There we go. And now we have our bricks nicely lined up in our world. Okay, so, and then that's, so it's quite easy to, so when we have something like this in Unity where we have to create a lot of objects and we need to lay them out in a fairly systematic manner, doing it by hand in the editor is often really bothersome. This is what code is for. It's for allowing us to do long repetitive tasks quickly by writing code to do it and doing it automatically rather than doing it by hand. So a lot of games where you've got level generation in a game, for example, you'll do this kind of thing. You'll have code to generate the level. And what we'll be doing in today's tute is picking a bunch of different patterns other than a rectangle and writing some code like this to generate other patterns. So you can go and look at the tute and see how they would work. All right, so that's all the things. Now we've got all the things in the world, right? So now we need to actually start making things move. So we'll start with the paddle. And we'll actually, I'll create a folder in here for scripts, because we just don't want to organize it a little bit better. And I'll create a script called move paddle. Okay, so now this is simple. We've already done a bit of this before. We say we want to move left and right as when user presses left, right keys. Okay. So notice when I'm commenting my code, the comments are more or less sort of a high-level description of what the code's going to do. So we say, now we have an if, then we want to check if the user's pressed left, move left, else otherwise if the user's pressed right, move right. Okay. So we can do that in order to know whether or not what key has been pressed. We've got the input, I've got to remember, is it get key down? Okay, get key down, and that's the left key, and we can copy and paste that down here for if we've pressed the right key. Now, interesting question here is what happens if the user presses both the left key and the right key at the same time? Well, what happens here is it says if the left key is pressed, we'll move left. Otherwise, if the right key is pressed, we'll move right. So if the left and right key are both pressed down, this will move left because the first one will happen rather than the second one. We could actually change the code so that if we left out the else, whoops, if we left out the else, then this would say if the left key is down, it would move left. If the right key is down, it would move right. So if both of them are down, this would move the paddle left, this would move the paddle right, and the paddle would presumably end up being in the same place as it was before. So, I mean, there's a small difference there. This is probably the right thing to do in this case. If you press down both keys, you should probably not move the paddle. So there's a slight difference between whether or not we have the else there. The else, if we have the else, then the second one will never happen if the first one is true. Whereas in this case, without the else, both of them can run if both conditions are true. And since it is possible that both conditions are true, the right thing would probably be to handle that appropriately. Okay, so moving left, that's easy. We say transform dot translate, and we say vector 3 dot left. Here we have it, and we want to have a speed, so let's put a speed in there, and we also want to have a time dot delta time in there. You'll notice some of my code I've left out the time dot delta time. It's really important that you put it in there, because if you actually compile any of those scripts that don't have that in there and run the compiled version rather than running them in Unity, you'll find that they run awfully fast. Because when you're running them in Unity, it runs things fairly slowly. But when you run them, when you build them and then run the application, it runs an awful lot faster than it does when it's running in Unity. And so if you don't have this time or delta time, your game will run an awful lot faster when you compile it, when you build it, than when you haven't built it. So let's say speed, and again we'll pick it's a float, and we'll pick a number like 1.0 just for starters. And we can take this same line of code and put it down here, and change left to right, and that should now move us right when we have that. So let's go check that. We'll put the move paddle onto our paddle. Now we're here, we're pressing left, and it's not working. And why is it not working? Okay, it is working, it's just moving a very tiny amount. Okay, it's actually, okay, so it's moving very, very slowly is one thing. The other thing is that it's only moving, the get key down method only happens when you press the key, like once when you press, it only happens when the key changes from up to down. It doesn't happen as long as the key is down. So I chose the wrong method there. So let's first of all fix that. So that shouldn't be get key down, that should actually I think be get key. Right, now if we play, oops, play. Okay, while I'm holding the key down, it's moving awfully slowly though, so we might want to increase that. Right, so we'll go back to the paddle, take that script and change that speed to say 4. That's better, it's still probably a bit slow. Let's change it to 5. Yeah, it's not bad, it's not great. I like something a bit faster, 8. That feels good. Okay. Now we have a problem, is that we can move too far. So we don't want to move through the walls. There are various ways we could do that, but the easiest way is to actually just check for a collision. Because if we make the paddle into a trigger, and if we go to each of the walls, and make each of the walls also a trigger. Now, because the walls are static and never going to move around, we can leave them just as static colliders. But the paddle we need to, if we want to detect collisions, we have to have a rigid body as well. So the paddle, we need to add a rigid body to the paddle. And like we said, we want it to be kinematic, which means we're controlling it ourselves. And now, so that shouldn't actually change anything in the game, right? Still plays the same way. But now when we have a, actually that's probably not the, what do we need to do? So that'll trigger an event, but it won't, okay, so what we can do, okay. What I'll do is like this function on trigger enter. Actually, that's probably, well, we'll see what happens. On trigger enter. with another thing, and we'll say if other.gameObject.compare tag with wall, we've hit a wall, stop moving. Okay, now in order to make that work, we've got to tag our walls. So we're going to come up here, we're going to add a new tag to our thing, and we're going to create, open up tags, create a tag called wall. I think I used lowercase. Yeah, lowercase. It's got to have the same case there. So okay. So now we need to tag all our walls with the wall tag. So we come to our left wall and we tag it as wall, and the right wall is a wall, and the top wall is a wall. All right. So now we can, well, we didn't really need to tag the top wall in this case, but well, what we'll do, I'll show you if we print out other.gameObject.name. Now when we run, again you won't be able to see this, but when we, okay, so if you look in the video now, you'll be able to see down here it's printed out left wall because we've collided with the left wall. And if we hit there, it should say right wall because we've collided with the right wall. And, but it still doesn't actually stop us from moving through them. So that's a problem. So what we can do is, now there's a difficulty here because we're moving in this code here, and this code is going to translate us even if we're collided with something. So what I'll do is we'll actually create some state in here. We'll say hit left wall is a Boolean, and that's initially false. And we'll also say hit right wall. Actually, I don't know whether this method of doing it's going to be the best way of doing it. So this come to the point where you've got to stop writing code and actually think a little bit more about your design. I've got to work out how to tell this code that I'm not allowed to move. So what I could do is say, if the input key is left and I have not hit the left wall, then move left. So we haven't actually looked much. I told you about Boolean expressions, but we haven't looked at much in detail yet. But we can actually compare, if we take two Booleans, we can sort of combine them together in an expression. So the exclamation mark means not. So if hit left wall is true, exclamation mark hit left wall is false, and vice versa. So this means if we hit, and the and is just, the double ampersand just means and. So this says if the left key is pressed and we have not hit the left wall, then we're allowed to move left. And then we'll have a similar thing down here. If the right key is pressed and we have not hit the right wall, then we're allowed to move right. Then what we can do here is, actually this is getting messy because we now need to distinguish between the left wall and the right wall. Actually, I'm going to do it this way. Turns out I should have thought this through a little bit more. Trying to do it with a trigger is probably a difficult way of implementing this. And we're out of time anyway. I'll think about a better solution for this, and for the next lecture I'll work out how to do that best. But anyway, so for today's lab, what you're going to be doing is writing a couple of variations of this create bricks script. So I'll put this up on the website for you to download. But what I want you to do is create bricks in different shapes. So if we can read this, yep. So you'll be making triangles and diamonds, and if you're really up for a challenge, making bricks in a circle. But you're using more the same sort of procedure. So making layer by layer, and then for each layer making it brick by brick. It's just that in this case each layer contains fewer and fewer bricks, and then there are more complicated cases about how you decide. Each layer has bricks, but it also has some sort of arrangement. That's for you to work out in today's lab. All right, thank you very much. I'll see you in labs.